All right, so we're actually going to call this Day 2 and Day 3. We'll cover it in class in separate lessons. But in this lesson, it's the same topic. We're producing graphs and kind of looking at, well, I don't want to use the term function because they're a little bit different, but graphing equations of polar coordinates, I guess, is the best way to look at it. Both days are the same concept, it's just additional practice. Well, here's kind of the big idea that you have these points, r and theta, and kind of the way it works here is you think of theta like x and r like y, and you plug in an angle into a graph that's in the form of polar coordinates, and from there you plot the points just like we did in the first day of 11.1. All right, so just remember that. I think it's the best and most straightforward way to think about it. Think of theta being like x, and then think of r being like y. I use those references because graphing functions in terms of x and y is something we're way more familiar with than polar coordinates. But that's the idea. So here's what I'm going to do. I'm going to do a couple of these. I'm not going to do the whole table. It will take a little bit of time. You'll see on your homework assignments for 11.2 and 11.3, they're relatively short. There's not a whole heck of a lot to them. So I'm just going to do the first few points and then leave you from there. So here you've got all these values for theta. Remember that's like x, this r. I'm just putting it in quotes because you shouldn't have like a literal association. It's just a way to think about it. There's kind of like your y. There's theta, which is kind of like your x. So this first point here in the table, I'll just do a couple of them. You plug in 0, okay? 0 degrees. The very first thing you do is multiply it by 2. Well, that's still 0. Unit circle is going to come in really handy because typically if theta is like x and we get to pick those values, we like to pick values that are on the unit circle. Okay, they're easier to work with. So the sine of 0 is 0 times 2, 0. Okay, so r would be 0. Not a lot going on there. Let's look at a more interesting one. The very next one in the table. What if we substitute in 30 degrees? We multiply it by 2. We get 60. Okay? The sine of 60 degrees is 1/2. Okay? Oh, excuse me. Sine of 60 degrees, square root 3 over 2. Okay, I was still thinking 30. You got to remember to double it. This one's a little bit tricky because it's got the 2 theta in there. Okay, but the very first thing you do is double it. So square root 3 over 2. Then the last thing you do is multiply that by 2. So if I had square root 3 over 2 times 2, that cancels. R would be square root 3. Okay, let's do one more. Then we'll move on to a different one. You should finish these though, all right? Finish the table and plot the points. But if you get a good table first, plotting the points is no different than it was in the first day. 45 times 2 is 90. Sine of 90 is 1 times 2 is 2. It's really not, if you just kind of factor in the variable names being a little bit different, it's not different than evaluating a function in terms of x and y. It's really we've made graphs and made tables, a ton with x and y. We spent a whole semester on that with functions. Okay, so 0, 0. I'm going to just kind of zoom into the graph here and show you. So we got 0, 0. Now I'm going to change the units here a little bit. Let's say that's 1. And that's 2, okay, just so I have more space. So the next one was when I put in 30, I got square root 3. Here it's a good idea to be thinking about decimal approximations. The square root of 3 is about 1.7. So when I go up 30 degrees, okay, that would be at pi over 6. That's 30 degrees. I would go up to, well, I'd say a little bit farther than that. That would be 1.5. Put up there. And then when I put in 45 degrees, I got a R value of 2, and I would start to connect these, okay, like this. You'll see all kinds of funny shapes. This one ends up looking like a flower petal, okay? 4 different flower petals. So finish that one off, and every single one would be the same way. The key is to just kind of take it one at a time. Here's one that's a little bit different. 1 minus sine theta, okay? Treat theta like x, treat r like y. Okay, sine of theta is, sine of 0 is 0, and 1 minus 0 is 1. Okay, now here, when you're putting numbers in the table, the square root of 3 over 2 is going to come up quite a bit. Come to think of it, let's see here. Yeah, let's just use these two. Use some decimal approximations for those. They can be a little bit tricky. I gotta double check here on a calculator. Square root 3 over 2. It's 0.8 something. I gotta verify if we're gonna go to 2 decimal places. I should have it exactly. Square root 3 over 2. 0.87. Yeah, that didn't feel quite right. Okay, so for example, in this very next one, when I do sine of pi over 6, that's a half. 1 minus a half is a half. Now get to pi over 4. Okay, so I'm substituting pi over 4 and then evaluating on the unit circle. That's square root 2 over 2. Okay, the exact answer would be 1 minus square root 2 over 2. Do 1 minus 0.71, because when you get to the graphing part, it's good to have numbers on there that are intuitive and you can gauge how big they are and how you should plot them. But that's what that one would look like. Here's a third, cosine of 2 theta. Same idea. The very first thing I would do here is plug in 0 for theta. All right. Yeah, I know the table takes a long time, but be thorough with your table. Make a good one. It's the most straightforward way to go because the plotting part is the same as the first day if you have a table that's accurate and reliable. Okay? It's the same through both days. Producing these tables and sketching graphs of trig functions that are in polar coordinates.